Hello, this is Mr. Stansbury. I'm going to take you through the 10F assignment. Okay, so let's start here with number one. Find the area of these three triangles. Okay, so we have this area formula here, which is 1/2 AB sine C. Remember from the notes, lowercase letters stand for sides and uppercase letters stand for angles. So basically what this is saying, you can find the area if you know an angle and the two sides that are on on either side of the angle. Okay, so this here, again, it's kind of nice because they didn't actually assign letters on this. So if you want to assign letters, that might make it a little bit easier. So this here is the only angle, so that it has to be C. So we could call that C. And then we can call this angle up here either A or B. It doesn't matter. Capital A, capital B. And so then that would make these sides over here, this would be side little c, across from A is side little a, and across from B is side little b. Okay, so if we use this lovely formula here, for A, we'd get area equals 1/2 of A, which we know is 10, times B, which is 9, times the sine of angle C, which is 40. Okay, so it's just the angle and the two sides that connect that make that angle. Okay, so not really sure we have an equal sign there. It's area equals that. So we should be able to just plug this into our calculator and away we go. Okay, so we've got 1/2, which is 0.5 times 10 times 9 times sine of 40, and you shouldn't have to do times sine of 40, but it doesn't hurt. Okay, it should give us 28.9 centimeters. 28.9 centimeters, and since it's area, it should be centimeters squared. B, here's our angle and our two sides. Okay, so we can do what we did before. So here, this will be angle C. Let's call this, doesn't matter if it's A or B, we'll call that A, that B. So that makes this across from big A is little a, across from big B is little b, and across from big C is little c. So the area is going to equal 1/2 A, which is 31, times B, which is 25, times sine of C, so sine of 82. Okay, so again, we'll just put this into our calculator and away we go. So 0.5 times 31 times 25 times sine 82. Right, 383.72, so we'll call it 383.7. And this is kilometers, and since it's area, it'll be kilometers squared. Okay, all right, with C, I'm going to not draw my letters in there, and I'm just going to kind of go straight to the area formula. So we got area equals, because we have two sides, and those two sides make up that angle in between that we know. So it's just going to be these two sides, so we're going to go 1/2 of, let's call it 6.4, times 10.2 times the sine of the angle, sine of 125. Okay, so again, we should be able to put that into our calculator. So 0.5 times 6.4 times 10.2 times sine of 125 gives us 26.73, so we'll call it 26.7 centimeters squared would be the area of that triangle. Okay? Okay, let's move on to the next one. Number 2, if triangle ABC has an area of 150 centimeters squared, find the value of x. So, let's do this. As soon as they give you a triangle, if you're really wanting to put the A, B's, and C's in there, as soon as they give you a triangle, just scratch out the letters that they give you, and then we're going to reassign the letters so that it'll work for our formula. So we want the angle that we know to be angle C, so we're going to call that C. So that would make this side over here little c. And then the two sides here have to be across from A's and B's. So let's just call this A. So that would make this little a. Let's call this B, and that would make this little b. So now we can use our formula here to figure out the value of x. Okay, so we'll have area equals 1/2 of side A, which is 17. Actually, I'm going to back up here because we know what the area is. The area is 150, so we'll do 150 equals 1/2 of A, which is 17, times B, which we don't know, is x, times sine of 68. Okay, so what we're going to do here is, we know that this is just going to be 150 here. And then what we're going to do is we're going to multiply 1/2 times 17 times sine 68. And we're going to still multiply that by x. But we don't know what x is yet, so we're just going to do 0.5 times 17 times sine 68, just like we were talking about. And that gives us that these three numbers that we do know, these three values we know, are going to multiply together to get 7.88. So we're going to call this 7.88, but we still have an x in there, right, times x. So to figure out what x is, we would just simply divide both sides by 7.88. And that's going to tell us what x equals. So we'll take 150 divided by 7.88. We get 19.03, so we'll call that 19.0 is what side x should end up being. Okay? Okay. Moving on to the next one. Number 3, parallelogram has two adjacent sides of length 4 and 6 respectively. Okay, so let's draw parallelogram. It's got sides 4 and 6, so we'll just kind of guesstimate here. So we'll call that 4 and that's 6, so that would have to be 6 and 4 as well. If the included angle measures 52 degrees, find the area of the parallelogram. Okay, so 52 looks like it's going to be the smaller of the two, so we're going to say that this here is going to be 52 degrees. Okay, so some people are thinking, it's like, hey, wait, this gives us an area of a triangle, but we have a rectangle. So what we can do is just do this. Let's just take this rectangle and cut it in half, right? So now we can find the area of this triangle here. And then guess what? The area of this triangle is going to be the exact same as the area of that triangle. So then we'll just end up finding this area, and then we'll double it to find the area of the rectangle, of the parallelogram, excuse me. Okay. So if we're using this one here, that formula, which we will, so the area of this is going to be the 1/2 of the two sides that make the angle. So 1/2 of 6 times 4 times sine of the angle 52 is going to be the area of half of that, right? Oops, let's see, there we go. There it is. So we'll do 1/2 times 6 times 4 times sine of 52, right? And that gives us 9.456 is the area of half of it, but we don't want half of it, we want the area of the whole thing, so let's just double that. So times 2 gives us 18.9, we'll call it. So area of parallelogram is going to equal 18.9, isn't that what we said? Yeah, 18.9, and this is going to be centimeters squared. All right? Okay, moving on to the next one. Number 4, part A. Find the area of triangle PQR to 3 decimal places. So PQR. So this whole thing right here. So that shouldn't be too bad because look, we have the two sides and the angle in between it for that triangle. So that'll work out just fine. So area is going to be, oops, for part A, area is going to equal 1/2 of the two sides multiplied together. So 17 times 14, or 14 times 17, doesn't matter, times sine of the angle that's between those two sides, sine of 37. Okay, so area is going to equal, excuse me, 0.5 times 17 times 14 times sine of 37 gives us 71.6, and that's going to be meters squared for the area of that triangle, right? And then now from that, part B, hence find the length of the altitude from Q to RP. So basically they're saying figure out what this length here is. Okay, so really what we can do is we can use our good old everyday area formula for a triangle, which is area equals base times height divided by 2, right? So since we know the area already, we can say the area is 71.6 equals the base, which in this case is 17, times the height, which is what we're looking for. So instead of h, let's put in x, all divided by 2. Okay, and then now we're just going to solve this. So a couple ways to do this. I'm just going to do this. 71.6 equals 17 divided by 2 is going to be 8.5x, right? So to figure out what x is, just divide by 8.5, and we'll get that x is equal to whatever that is. So 71.6 divided by 8.5 gives us 8.42. So we'll call x equals 8.4 meters. All right. Okay, moving on to the last one here. Number 4, an isosceles triangle is drawn with base angles 32 and base 24 centimeters. So let's do that. So the base angles of an isosceles triangle are going to be these, 32, 32. We're saying that these two are the same. And the base is 24 centimeters. Find the base angles of an isosceles triangle with the same base but double the area. Okay, so what we need to do is we need to let's do this first. Let's figure out what the area of this is going to be, so we can draw ourselves a little a height, an altitude in there. Okay, so let's see, we now cut this side in half, so this is now 12. So let's find this altitude here. Okay, so we can say here's our angle, this is the opposite side, this is the adjacent, right? So the opposite and adjacent is tangent, so we can say tangent of 32 equals opposite, which in this case is A, over adjacent, which is 12. Multiply both sides by 12, right? So we have, so we'll do 12 tangent 32. 12 tangent 32 gives us 7.5, right? So our altitude is going to be 7.5, what are these, centimeters? So this here, I'll write it in red so we can find it easier. 7.5 is that altitude. Okay, so now we can figure out what the area of this is here, of this whole triangle, right? Because it's just going to be 1/2 of the base times the height. So we don't have to use this one just yet. Okay, so let's do that. So area is going to be base times height divided by 2. So the base is 24. The height is 7.5 divided by 2, and that'll give us the area of that triangle there. Okay, so 24 times 7.5 equals, divided by 2, gives us 90. Okay, so the area of the triangle is going to be 90 centimeters squared. So now it says find the base angles of an isosceles triangle with the same base, but now with double the area. Okay, so let's do this part here in green. So now we know that the area instead of 90 is going to be 180, right? So we know the base is still the same, so we can still use area equals base times height divided by 2. So the area now is going to be 180. The base is still 24. The height is what we're looking for now, and it's still divided by 2, right? So that's going to be 180 equals 12h. So divide both sides by 12. And we get 180 divided by 12 gives us that the height is now 15 of the new one. So that's not going to give us the base angles yet, but it is going to tell us that this height is now 15 centimeters. Okay. Now, one thing that I purposely did not tell you is, if you'll notice, if we know that the base is going to be the same and the area is going to be twice as much, if we've got area is going to be base times height, only way for that this triangle to be twice the area is the only thing that we can change in this formula, because we already know the area is going to be doubled, the base is going to be the same, is the height. So if it's going to be twice as big, this height's got to be twice as tall. So if you'll notice, 7.5 times 2 is 15. So we did a whole bunch of extra work to figure that out, but there are some easier ways to get to that. But now that we have the new height is 15 and we still know that this is 12, we've got to figure out what this angle is here. So let's redraw our new triangle, but I'm just going to redraw one side of it. Okay, so now we know that the altitude is now going to be 15 instead of 7.5, and we still know that this is 12. Now we just have to figure out what that angle there is, right? So this is opposite, this is adjacent, it's going to be tangent. So we do tangent theta is going to equal opposite, which is 15, over adjacent, which is 12. Okay, so since we're looking for an angle, we got to do second tangent of 15 divided by 12, and that gives us 51.34. So the new angle is going to be 51.3 degrees. Okay, that's not our answer. This one is here. Okay, so our new angle, 51.3 degrees. All right, that's all there is here for 10F problems. If you have any further questions, please feel free to ask in class. Thanks.